Alright, so let's start with the problems up and on the board yesterday. Alright, so, well, before we do that, let's go back through our list. What's the first thing we're going to look for? Before that, nth term. Technically we're doing nth term. If you want to
following that double flow chart.
That he threw away.
you threw it away.
He recycled it. Sorry, but it's gone forever.
What day is recycling? Is it today or is it Thursday?
Thursdays. Oh dang it! It's tomorrow.
Alright, nth term test, geometric,
P series.
P series. Then after that,
Comparison. Integral.
integral, comparison,
Ratio.
limit, ratio,
Root.
root, alternating. Is that all of them?
Yep.
I think that's all of them.
Sounds good.
So, on this one up here, what do we do on G?
Ratio.
Ratio?
Sure.
And remember, when we do ratio, I haven't been doing a very good job of it, but when we do ratio, we need to be doing absolute value. So the absolute value of -3, that'd be n plus 2, over 2 to the 3 n plus 1, times 2 to the 3 n, -3 n plus 1. Alright, so there's that, so we need to know what's left. I'm interested to see if you guys got what's left correct. So what's in the numerator?
3.
3 is in the numerator. I agree with that. What's in the denominator?
2 to the third.
Say it again.
2 to the third. 8.
2 to the third. Okay. So 2 to the third. Is that it?
That's
Yep.
all I have.
That's it. Alright, I'll go
Would it
with
be
that.
3 or -3?
No, we're doing the absolute value, so it's
Oh,
going to be 3.
well. Lines.
So that ends up giving me 3/8, and then what do I need to say about 3/8?
Less than what?
It's less than 1.
Convergence.
Converges. Absolutely. Ratio test. There we go. Very good. Question on that. Alright. So then H. This one is interval test, correct? What's usually a key to interval?
Don't do it.
What usually helps you identify this interval?
If you use substitution.
If you use substitution works, it's usually interval. What do we have to show if we're going to use interval? Or what do we have to say?
Positive, continuous, decreasing.
Alright. So we are considering f of x equals 1 over x square root natural log of x.
How do we write that?
If you're going to show it's decreasing, yes. So then Kevin had fun with the derivative of this thing yesterday. So that's bottom. Bottom, derivative of the top, minus the top, which is 1, derivative of the bottom, which is requires product rule, so that's first, derivative of the second, so 1 over 2 times the radical times the derivative of the radical, plus the second, derivative of the first, all over the bottom squared. So that's gone. This x and this x cancel. So I have 1 over 2 square root natural log of x plus square root natural log of x. Now, I think if I remember right, Kevin, you cleaned up the denominator, which is unnecessary, because all I want the denominator to be is what?
Positive.
Positive. So I'm just going to leave it as x square root ln x squared.
Where's your
Say it again.
Where'd your negative go? From the minus.
Thank you.
Uh-huh.
So then f prime of x, get a common denominator. I'm going to have negative 1 plus 2 square root natural log of x, and that's all over 2 square root natural log of x times x square root natural log of x squared.
Shouldn't that just be 2 natural log of x? Since we multiplied by the square root of natural log of x.
You're right. Thank you.
Okay.
Sarah?
On the AP test, if you were to leave it at, let's say, the second step, are they going to be like, that's not enough?
Oh, that's a good point.
Because
That's a great
if
point.
you're like, it's the only test that's going to work, so it looks
Yeah.
like it's decreasing.
That's a great place. That's a great point. So this right here, I could stop right there and say that's. I'm with you. Good call, Sarah. So yes, at this point right here, I know that thing is negative, therefore I know it's decreasing. Alright. So I know, I can now state it, I know that 1 over n, I know that's greater than 0, and I know f of x equals 1 over x ln x is greater than 0, or sorry, continuous. I know that's continuous and decreasing. So I've done the setup that's going to allow me to do the integral test. This is why we don't like the integral test. There's a lot of setup. So now we want to do the integral from 2 to infinity of 1 over, we want the x, don't we?
Yeah.
So 1 over x square root ln x
DX.
dx. So our u is the natural log of x, which gives me the 1 over x. So I'm integrating the negative 1/2, which turns into positive 1/2 with the 2 out front from 2 to infinity. So we're technically doing the limit as b goes to infinity of 2 and that equals infinity, and therefore this series diverges integral test.
I have a question.
Yes.
If I wanted to, where you first put the infinity in the integral, could you just put b there and do the limit as b, and you can use it all the way down to the end?
All right, very good. Sounds like you guys got it. Maybe better than me. All right, So I've come to the point where anytime I see factorial, ratio, that's what I've come to do. So the limit as n approaches infinity, 3 to the n plus 1 over 2 to the n plus 1 factorial. And this is the one I'm interested in seeing whether or not you got it correct. Now, since it's ratio, in this case it doesn't matter, but so this one's the one I'm interested in whether or not you reduced it correctly. So what'd you get when you reduced this one? 3 on the numerator. And it's the denominator that I'm interested in seeing whether or not you got it right. Very good. You guys get that?
Yeah.
Kevin, help me.
Can help you. Did you see it? So the limit of this thing is 0, which is less than 1. Therefore, converges absolutely ratio test. Very good. You guys are so smart. All right, J. So this is the one where I told you to use the properties, so we rewrote it, is that
Yeah.
correct? That's 1/2 natural log of n, and we want to compare that to,
1/2.
now here's what I've done a poor job, is when we're comparing to see whether or not something is greater than or less than. You want to start with the denominators. Okay, so the denominator that's going to be similar to 2 natural log of n is 2n. So I want to start with the denominators and compare those two. So which one of those two is larger? 2n is larger. So I'm going to state that. Then I'm going to divide both sides by both sides, if that makes sense. Which gives me that. Is that right?
Yes.
Okay. So this shows me that this is larger than this. So when I find out that what I'm comparing to is smaller than the other one, which one am I, what does it need to be? Does it need to be divergent or convergent? If what I'm comparing to is going to be smaller, do I want it to be divergent or I want it to be divergent? The smaller one needs to be divergent. If it's bigger, then we want it to be convergent. So that means I'm hoping this thing right here is divergent, which it is. And why is it divergent? P series, P is equal to 1. Okay, what's another thing I could say? It's a harmonic series. I think harmonic series is probably the easiest thing to say. So that's harmonic, so then I can say that this one is divergent as well. And what's my reason? Direct comparison test. Now, a lot of places, a lot of other books I've been reading it online, they don't say direct comparison test, they just say comparison test. So keep that in mind if you want to save some writing. You could just write comparison test.
That just seems confusing because there's limit comparison.
Right, so I guess when if you're not putting anything in front of it that's understood to be direct, if it's limit, then you need to say limit. Alright. So this one was my favorite one. Alright, so anytime I see a sine or a cosine, I usually want to set up an inequality. And in this case, I know this thing right here has to be less than or equal to 1. Everybody agree with that? Okay. Now, since the denominator of that fraction is n squared plus 4n, that means I want to divide both sides by n squared plus 4n. Which gives me that. Okay. But I don't want to compare to this, because if I do, then I have to do what Sarah did and do a double direct comparison test. So I ultimately want to compare that to 1/n squared. So I start another thing over here and say n squared plus 4n is greater than n squared. And I divide both sides. And I have that. So 1/n squared is greater than 1/n squared plus 4n. Which means I can make that statement, and this statement tells me that I have that.
Right.
So now I can compare and I know this one converges because of y? P series. Which means the original converges because of the comparison test. I like that. That was fun. Alright, now, other worksheet I gave you yesterday.
The actual worksheet?
The actual worksheet. I guess I only gave you one. Any questions on that? Because I feel like we went pretty much
Kinda-
over all that
yeah.
together already. All right. So what we have not practiced yet are what? The remainder problems.
Yeah.
Do we want to do one of those? Or you guys good on that?
I want to do at least one.
Oh,
You wanna do
one.
one?
We're just holding it over.
Yeah.
No. There's more ivy. No. What's that? So, A, B, E, and N, T, B. Everything, every single letter. I didn't count letters, so we can. But this type of time.
Okay, and we want to do this one to an error of within. I think we can do this one. All right, so there's my sum. I want to do that to within an error of 0.0001. So how do we get started?
Inequality.
Inequality. So 2 to the n plus 1 over 4 to the n plus 1 plus 1 equal, or sorry. And since it's within, I don't want the equal to, just the less than. Give me that. Everybody okay with that?
Yes.
Alright. So what do we want to do from here?
Plug in.
No,
You can plug in numbers if you want.
Mm.
if you turn it.
I would probably do- I would probably do that.
Yeah.
Makes it easier to see.
Do you need? Oh.
Oh,
So then at this point, we want to plug in until we get something that's larger than
Evan,
10,000. You guys do that for me real quick.
Evan.
Do that. Do you do that in a calculator?
Yeah. Use your calculator, plug that in. Yeah, let's go.
You're on it.
Or Nick.
Is there any way to guess what it might possibly be? Like,
Yeah.
how do you look at it and
Yeah.
think it's gonna, or do you just pick a
27.
number and start somewhere? And,
I would start somewhere. I would start at maybe 10.
10? Okay.
27, go 27.
Like n equals 10?
Yes.
Calculator?
No.
Oh, I need you to give it to me.
Did we made our test yet?
It's a 27, go.
That's not a real calculator, Connor. I need a real boy calculator.
Well, then it's bad.
Oh,
Do it by hand.
Do 18.
I'm stealing your calculator, right? But I'll give it back, I swear.
18.
That's
Oh, wait, wait, wait,
No.
oh, where's bigger? I'm sorry.
small.
13.
Yeah, I think it's 13.
13,
So did you get 12 point something?
Yeah, it's 13.
13?
You get 12.2877.
Okay.
What did you do? Move the 1,000 over and solve it?
Yeah, I just did numeral solve, set it equal to 1,000.
Gotcha.
And round up.
So you can do that, or you can plug in until you find something that works. So we get 13 to work. So that means I want to estimate that.
You guys can figure it out.
Believe me,
I don't.
we have great expectations. You started at 7. Do you think I know?
I captured all of that.
What'd you get?
Or 32,764. 499.
Wait, it is.
I got 1 point something.
There you go. 1 point something is what it is. What is it, Kevin?
1.382. How many decimal places do you want?
1 past that.
Oh, so
I forgot something.
9, 7. That should be good, right?
Okay. So then I need to find A of what?
14.
I need to find A of 14. So 2 to the 14th over 4 to the 14th plus 1.
Oh.
Point 4 zeros. Then a 6.
And a 6. So that means the actual value. I add 4 zeros and a 6, so that's 1.38303. Is that right?
Yeah.
And that means this is 1.38391. Does that look right?
Is it
291?
291? Yeah, how did I miss that?
How was it 17 this year?
There it is. So the actual sum of that has to be between 1.38291 and 1.38303. Very good. I think that covers it all. What do you think? Does that cover everything?
How long do you think you'll make the test?
25 questions.
No.
Make it 100 questions so I
That's
can
gonna be a
miss a
two-part
bunch
test.
of them and still do okay.
Well, I have to figure out how many you can done in 50 minutes.
Not many then.
3.
They all will be reviewed.
Probably like
So I probably won't be able to get all the tests in there.
no, that's fine.
You
Give
put
us
a
a list.
calculator or
Like,
no
take out what
calculator?
wasn't gonna be.